Okay, in this video, I'm going to explain about buoyant force and Archimedes principle and using one problem set. We're gonna go through how to solve the problem set about the buoyancy force. Buoyancy force is the force that is gonna apply to an object in fluid. And when you wanna solve the problem set of the buoyancy force, it's pretty simple. You only have to deal with upward and downward pressure or force in fluid. So basically up and down, these two are all you need to know. And when you deal with the problem set of the buoyant force, of course, these are all about the object in fluid. So you have to deal with the density of the fluid. And another thing is, upward hydrostatic pressure. Hydrostatic pressure and gravity. Since, of course, you cannot change the magnitude of gravity on this Earth, these are only two biggest parameters to determine the buoyant force. And actually, it's pretty simple. There are not many things that you should remember. There are only two. So one is hydrostatic pressure, so which is P, and P can obtained as low. This is the density of the fluid. Multiplied by h, which is the distance from the surface to the object. And you multiply by g. This is gravity factor. I always recommend you to use the same unit since the unit conversion can be trouble. So I recommend you to stick to this unit, which is kilogram or meter or second or Pascal. Of course, for unit, you can use pound or gram or stuff like that, but the kilogram is the standard for the weight. And same things for length, which is meter or like second, time, and PA is Pascal, which is the unit for pressure. And another important equation that you have to know is force equals to pressure multiplied by area. So it's pretty simple, and these are all you need to know. So let's solve our problem set with only this knowledge. You should be able to solve this problem. Okay, let's go. Here we go. Plastic block with a volume of 1.4 multiplied by 10 to the negative 4 meter cubic is floating in water. When a metal object is of weight m equals to 120 gram, which is 0.12 kilogram, is placed on the top of the block. The system is in equilibrium. And the top of the block is the level of water. So let's draw a cartoon so that we can understand the situation here. So there is a big container filled with water. This is water. So the water density is usually 1,000 kilogram per meter cubic. And the plastic block is floating. And there is a metal object. Metal and plastic. And the water level is at the top of this object. So this is like this. And what we have to determine is the density of the plastic block. Okay, so we have to get this density. And all because we know the volume of this plastic object or block, we need to get the weight here. So let's say that the plastic weight equals to W kilogram. And this is what we need to know. And in order to, because we are dealing with the hydrostatic force, anyway, we are going to need this length. So let's say H here. And let's say this cross-section area is A, so that we can make an equation. And like I said, if you study or if you trying to solve a problem set about the buoyancy force, you only need to deal with the upward force, and the downward force. And here, this word in equilibrium is important term, since this means that the upward force and the downward force is equal. And for downward force, there are two basically forces. One is gravity of this metal. Basically, this metal has like some weight, so it has some downward force. And of course, this object itself has a gravity as well. So there is a gravity from the plastic weight as well. And the upward force is, of course, hydrostatic pressure. So let's go one by one. So downward force. So like I said, these are two downward force. One is metal and one is from plastic. And the weight of the metal is 0.12 kilogram. And you have to multiply by G gravity factor. We have to make it force. And let's say this is W kilogram. So downward force is going to be W equals to W multiplied by G. So this is the downward force. Upward force is hydrostatic pressure, and hydrostatic pressure equals to using this equation. It is going to be rho multiplied by H multiplied by G. But this is pressure, not force. So you have to convert this pressure into force by using this equation. So the force is going to be rho multiplied by H multiplied by G. And you need to apply the area. So area is this one multiplied by H, multiplied by A. So basically, you're gonna plug this into here and this into here. So the equation is going to be rho multiplied by H multiplied by G multiplied by A equals to 0.12 kilogram multiplied by G plus W multiplied by G. And you find that this G can be canceled out because they are everything everywhere. And you might realize that this H multiplied by A equals to volume of this object. And this is already known, which is equals to 1.04 10 to the negative 4 meter cubic. So if you plug this number into this HA, and if you plug into this rho, which is the density of water in here, you can write this as 1,000 kilogram multiplied by 1.04 10 to the negative 4th meter cubic equals to 1.02 kilogram plus W. And this is cubic. So this is density. So, and you can cancel this out, and which is gonna give you 1.04 kilogram equals to 0.12 kilogram plus W. So W equals to 0.02 kilogram or 20 gram. And the question is to determine the density of the plastic block. So you have to get the density. Density equals to 0.14 divided by the volume, which is, so this is W. So density equal W divided by V, and the W is 0.02 kilogram, and the V is this number, 1.04 multiplied by 10 to the negative 4 meter cubic. So which is, if you use calculator to calculate this, you can get 142.9 kilogram per meter square. So this is the answer. It's pretty easy, right? And the B and C are, more easy. What happens to the block if the metal object is replaced by another metal object with half the mass? So basically, this object is gonna float up because you need to, because you have like less weight. So simply this is gonna float up a little. The number C, what happens to the block if the metal object is replaced by yet another object with twice the mass? So basically for this one, you also can use your common sense. If you have too many weight, basically this object is gonna sunk in. So this is gonna be the answer. So I hope you can understand this one, and I hope this was helpful. Just let me know if you have any question in the comments section. Thank you.